So, hello everyone. It is our next question. So, in this question, we are discussing about the torque, frictional torque, okay, and corresponding power loss. Okay. So now you can see here that there is a pipe, okay, like 15 long journal bearing arrangement. It is like this, okay. So in this, there is a soffit here. Okay, so the distance between these bearing and the soffit is 0.1 mm. Okay, and it is like lubricant here. So now soffit is 20 mm in diameter. So 20 mm in diameter, okay. And the rotational speed is rpm is 3000, okay. Now the dynamic viscosity of the lubricant used is 0.01 pascal, okay. And this varying length is 50 mm, okay. So this is data which is given. So now you can, I hope you know that linear velocity profile dy dy it is equal to uyt, okay, where u is tangential velocity of soffit, okay, and t is the thickness. Oil film, but where is oil film? This is oil film, okay. So now after that you also know that viscous shear stress tau is equal to mu dy, okay. So I can write it like mu uyt, okay. So now from here you also know the formula of the viscous viscous resistance, okay. Or I can write force on the bearing, okay. What is it? It is equal to shear stress, it is shear stress, okay, and into area of soffit. So here I can write shear stress is mu uyt into area is, it is like cylindrical, so 2 pi r, and l is length, okay. So after that I need to find viscous torque, okay. Viscous torque. Okay, so for viscous torque I need viscous force. Okay, viscous force into torque r. Okay, so from here viscous force is mu u by t into 2 pi rl. Okay, and what is torque arm? Torque arm is r. Okay, so according to given data we have given mu is equal to 0.01 pascal. Okay, pascal second, so it is equal to 0.01 newton second per meter square. And r is equal to, so here you can see that diameter is 20 mm. So from here I can take r, so r is 10 mm, so it is 0.01 mm, or no, sorry, it is 0.01 nm. Okay, after that I need to find L. Okay, L is 15 mm, so it is given. If I can write it in a meter, so 0.05 meter. Okay, so from here I can find you for you is equal to 2 pi r n by 60. Okay, so you know what is u is the tangential velocity of this surface, so u is equal to 2 pi r n, so 2 pi into r is 0.01 into n is the rotational speed, which is 3000 divided by 60. So after this solving this I can get 3.14 meter per second. Okay, so from here it is tangential velocity. Okay, so now I have t. Okay, so t is 0.1 mm, t is equal to 0.001 m. Okay, in meter. So from here frictional torque is t is equal to 0.1. Okay, so I can write like first formula mu u by t. Okay, and 2 pi r l and r. Okay, so it is the formula for frictional torque. So I can write now, they put the value from all of these. So t is equal to, what is the value of mu is equal to 0.1, u is equal to 3.14 from here. Okay, divided by t is 0.001. okay, and 2 pi into r is 0.01 and l is 0.05 and again r is 0.01. so I can get all the values from here which is given in the equations. Okay, so from here after solve all of this I get t is equal to 9.85 into 10 to the power minus 3 Newton meter. Okay. And there is another question in the given question that determine the corresponding power loss. Okay, so for this the circuit rotates with angular velocity omega. Okay, so I can write here circuit rotate with angular velocity omega. Okay, so omega is equal to 2 pi n. N is rotational speed. Y60 it is equal to 2 into 3.14. N is 3000 divided by 60, so it is 314 rad per second. Okay, so from here I can write that power utilized in overcoming the frictional resistance is P is equal to T tau. Okay, so I can get the value of T from here and tau from the here. Okay, so from T tau I can write 9.85 into 10 to the power minus 3 into 3.14. So after this all the calculation I get 3.09 Newton meter per second. Okay, and I can write in watt. It is 3.09 watt. It is the power which is required to overcome from the friction resistance. So I hope you are clear from here. If you have any doubt, then you can ask in the comment section. So thank you. Have a nice day.